Now one question is there, why the standardized tool is required for measurement? Why standard? Why tool of measurement be standardized? Why? जैसे मेजर कर रहे हैं चलता रहेगा, अच्छा रहेगा. माइंड इट. सपोज you are measuring certain thing with your span, so it will be, suppose I just have this one. So if you measure it with your hands, then it is 1, then it's 2, and then it's half, or you can say 4 and 3, 7. 2 and 7. So 2 hands are there and 7. 2 hand spans are there and 7 fingers are there. And if a person whose hand span is smaller, let us say this much, or the span is equal to smaller than this, so let us call this span is equal to this. So that time this is 1, this is 2, and then it will be 3, and then finger will be also 3 times. So now the same measurement according to the second person comes 3 hand span and 3 fingers. So if suppose we can take an example, आपकी नानी जो है मुंबई में है और आपके कोई बहुत फास्ट फ्रेंड, फैमिली फ्रेंड जो हैं वो नानी के यहाँ मुंबई गए हुए हैं, और आपने नानी ने कहा था कि भाई मुंबई में थोड़ा गोल्ड थोड़ा सस्ता है, तो मैं एक चेन भेज रही हूँ पोते के लिए, नाती के लिए, आपके लिए. तो उन्होंने कहा भाई एक चिट्ठी लिख दी और साथ में लिख दिया कि बेटा जो चेन भेज रही हूँ वो इतनी लंबी है, यानी अपने फिंगर से नाप करके किया होगा या इस हैंड स्पैन से किया होगा. हैंड स्पैन से उन्होंने क्या कहा, ये जो चेन की लेंथ जो मैं खोल के देखी होगी ऐसे करके 3 हैंड स्पैन्स एंड 4 फिंगर्स, ये नाप लिया. नानी ने नाप के दे दिया, चिट्ठी में लिख दिया. अब जो आपके फास्ट फ्रेंड हैं, फैमिली फ्रेंड हैं, वो अपनी जान को जोखिम में डाल करके उस गोल्ड को बड़ी मुश्किल से संभाल के हुए वहाँ से ला रहे हैं और आपके पास दे दिया. जब आपकी मम्मी ने चिट्ठी पढ़ी और उसमें लिखा था 3 हैंड्स 4 फिंगर्स, तो आपके पापा से कहा कि जरा इस चेन को नापना. अब पापा ने जब नापा तो नानी के हैंड स्पैन है और उनकी जो फिंगर्स हैं वो आपके पापा के हैंड स्पैन और फिंगर से छोटी हैं. तो पापा जी ने जब नापा हैंड स्पैन से तो इट केम 2 हैंड्स एंड 8 फिंगर्स. अब क्या हुआ, अब तो ये लग रहा है कि कहीं ना कहीं जो अंकल हैं उन्होंने चेन में कुछ गड़बड़ कर दी. तो देखिए, एक तो वो आपके क्या हुआ, बहुत मेहनत से लाए, इस वजह टाइम लगा के लाए, और एप्रिसिएशन क्या मिल रहा है कि इन्होंने तो कुछ गड़बड़ कर दी. तो गड़बड़ किसने करी है? वेयर इज द प्रॉब्लम? द प्रॉब्लम इज विद द टूल्स. अगर नानी ने उसको इंची टेप से या स्केल से नाप के दिया, लिखा होता, और आप भी यहाँ पर स्केल से ही नाप रहे होते, तो क्या होता, इट विल रिमेन सेम, और वो सेम आता, और फिर आप अंकल जी को थैंक यू भी कहते और उनका एहसान भी मानते. लेकिन अभी तो आपने जो है अंकल जी को कटघरे में ही खड़ा कर दिया. तो बिकॉज ऑफ द टूल्स. सो दैट्स वाई इस तरह की समस्याएं ना आए कहीं भी. द टूल मस्ट बी स्टैंडर्डाइज्ड. दैट मीन्स वेदर यू मेजर इट और आई मेजर इट और somebody else will measure it, the measurement will come the same if the person is not committing any error. अगर उसमें एरर भी डिस्कस करेंगे हम, तो अगर मेजरमेंट के दौरान कोई एरर नहीं हो रहा है तो टूल जो है, चाहे आप मेजर करें चाहे मैं मेजर करूं और somebody else will measure it, then every time the measurement will come exactly same. If suppose A measure से नानी ने measure किया 21.5 सेंटीमीटर, let us say, तो A measure करेंगे again 20.5 सेंटीमीटर, when B measure करते हैं then it will come again 25 centimeter. So there will be no problem. So that's why the tools should be standardized. So that's why we have different system of measurement. One is called the MKS, that means SI unit of measurements, and the second is CGS. This is the meter kilogram second system, and this is the centimeter gram second system. There was initially British system also, foot, pound and seconds. That was the British system. When the Britishers were here, then British system was foot, pound and second, FPS. अभी भी कुछ चीजें पाउंड्स में आप यूज करते हैं because of that. So this is a tool of measurement be standardized or should be standardized. Why the tool of measurement be standardized or it should be standard for everyone. Now we will have different physical quantities. So there are fundamental quantities, and there are 7 fundamental quantities. Number 1, length. Number 2, yes, mass. Number 3, time. 4th, electric current. 5th is temperature, yes. बहुत ठंडा हो रहा है, गर्म हो रहा है, वो किससे पता लगा? टेम्परेचर से. Then 6th, length, mass, time, electric current, temperature. Are you able to see it? Is the blackboard visible? Then due to what? That is the light. So light, luminous intensity. Luminous intensity. And 7th, this is what? Yes, amount of substance. Amount of substance. So the units, sometimes they are called fundamental quantities and basic quantities also. So basic units, I will write it here, basic units. For length it is meter, for mass it is kg, for time it's second, for electric current it is ampere, for temperature it's Kelvin, for luminous intensity it is candela, CD, then amount of substance is mole. There are 2 supplementary quantities also. One is plane angle or simply angle, and the second is solid angle. The unit of this plane angle is radian, and that is steradian. We have 7 fundamental quantities and 2 supplementary quantities. So try to define 1 meter, 1 kg, 1 second, and likewise, and try to find out the definitions of these units. We will discuss it later. Now we'll discuss here today derived quantities, derived quantities and derived units. Derived units. As the word derived quantities is concerned, itself it is self-explanatory, you can say. These are the physical quantities which are being derived using fundamental quantities or basic quantities. The basic quantities, I told you there are 7 basic quantities and 2 supplementary quantities: length, mass, time, electric current, temperature, luminous intensity, and amount of substance. Then supplementary are angle and solid angle. So here we will derive some physical quantities with the help of the basic or fundamental quantity. Let us say area. So area is not a fundamental, but it can be obtained with the help of basic quantities or the fundamental quantity, that is the length. If you take length twice and just multiply it, so area will come. So here the dimension will be meter into meter, that means meter square is the derived unit. So derived units are, you can define as the units which are being derived with the help of basic units or fundamental units. So fundamental unit is for length is meter, and since there are 2 lengths are being multiplied, so here also have to multiply these 2 units, that is meter square. Now you can have volume. So what will be volume? Length into length into length. So here it will be meter cube. Now what about the density? Yes, what is the formula for the density? Density is mass upon volume. So the mass is kg and upon volume is meter cube. You can write it kg meter minus 3 or like this. Whatever is convenient to you, you can use that one. Then fourth is suppose speed. Then what is the formula for the speed? Mind it, you will be able to derive these fundamental derived quantities or derived units only when you are very well versed with the formulas. So speed is distance upon time. So distance is again length and upon t. So length is meter and time is second. You can have ms minus 1 also. Speed is distance upon time. Just like density is mass upon volume. So mass is kg, volume is meter cube. So kg meter cube also you can write it. Similarly, if you have velocity. So what is velocity? Velocity is displacement upon time. Velocity is displacement upon time. So again displacement is what? The length, and time is t. So then unit will be in m meter per second, or you can say meter second power minus 1. Momentum. How you define momentum? The P equals to, yes, m into v. P equals to m into v. So here is the mass and here is the velocity. So this velocity is to be multiplied by the mass. So that will be m L by t. That means mass, one mass will be there, that is kg meter per second. Or you can say kg meter second inverse. Then impulse, J, that is change in momentum. So whatever it is, momentum, the change in momentum will remain momentum. Suppose you have 20 rupees, 10 rupees you buy some chocolate, then how much you are left with? That is 20 minus 10 is 10 rupees. So this change will remain the same. So it is momentum, change in momentum, that means the unit will remain same, that is kg meter per second. Now force is equals to m into a. Acceleration, so acceleration is a equals to velocity up, change in velocity upon time. Rate of change in velocity, that means change in velocity upon time. Change in velocity is what? Velocity upon time, and velocity is meter per second divided by 1 second. Again, meter per second divided by second, that will be equal to meter per second square. So that is to be written here, meter per second divided by second, that is meter per second square. So here mass into acceleration. So mass is kg and this is meter per second square. So that sometime also known as Newton. So N we use for force. So here see how the new physical quantities are being derived with the help of the fundamental quantities. That is why these quantities, these physical quantities are known as derived quantities. And similarly, here we are deriving the units for these derived quantities with the help of by multiplication or division, as is the formula, with basic units or fundamental units. So these are the derived units and these are the derived quantities.